Okay, so now we come to the third part of today's asynchronous lecture. Maximum and minimum values. Okay, so in this section, we come to the new section after related rate. Minimum and maximum and minimum values. Okay, so the learning outcome for this section is make sure you are able to understand what is so-called as absolute maximum, absolute minimum, local minimum, local maximum. Okay, so by definition, it is saying that a function f has an absolute maximum at c. Maksudnya c ni is the position of x, is the value of x. Okay, absolute maximum at x equals to c if for all x in the domain of f, fc ni value dia yang paling tinggi. fc is the maximum value of f. Whereas, okay, absolute minimum at x equals to c if kalau value c tu kita masukkan dalam f, it result the smallest value of the function. Okay, then the value of x dekat c tadi tu what we call as the extreme values, where it may consist of two extreme values of absolute maximum and absolute minimum. Faham Okay, tak faham tak apa. Don't worry, jangan stress. Okay, kita tengok example later on. Okay, and then for definition 2, tadi kita ada extreme or absolute. Okay, now we have what I highlighted here as local maximum. A function f has a local maximum, relative maximum at c sekiranya if fc is more than fx when x is near c. Kalau tadi kita compare dengan semua value of x dalam domain x tu. Okay, dalam semua value macam ni, maknanya yang ni yang paling tinggi. Tapi there's a condition yang mana yang kita ada macam ni. Macam tu for example. Okay, so for this one, yang ni kalau nak kira dia bukan yang paling tinggi sebab yang paling tinggi yang ni kan. However, this one is so called as local maximum or relative maximum because kalau compare dengan jiran-jiran dia yang kat sebelah kiri yang sebelah kanan ni, this point result the maximum value. Yang ni pun sama. Kalau compare dengan yang dekat-dekat, yang berdekatan dengan kawasan sekitar dia ni, dia yang paling tinggi. But of course, if we compare with this one, dia tak tinggi. Okay, so that's why we call it just local maximum. Local je, tak pergi peringkat international lah, lebih kurang macam tu lah. Okay, so hopefully you understand. Same goes for local minimum. Okay, local minimum kalau compare, kalau tengok yang kalau max minimum betul-betul, where we call it as absolute minimum, yang ni yang paling rendah. But this one and this one you may call it as local minimum because it's smallest value compared to dia punya jiran yang lain. Okay, yang ni lagi tinggi kan, yang ni pun lagi tinggi. Sama juga yang ni, kalau kawasan ni, yang ni what we call as local minimum. Hopefully you are able to understand and differentiate the difference between local and absolute tadi. Okay, alright. Okay, so saya rasa this example will help you a lot to understand. Okay, the question asks you, example 4, find the local minimum, maximum, absolute maximum for the function below. So we have x equals to a, b, c, d, e, and f. Okay, so can you give me local minimum? Local minimum at x equals to what? To apa? Local minimum at x equals to c, yes, equals to e. Minimum yang bawah c and e. C and x equals to e. Sebab boleh faham lah. Dia rendah compare dengan jiran-jiran dia ni, neighborhood area dia. Local maximum at x equals to apa? Yang berbukit-bukit ni lah. Okay, at x equals to b and x equals to d. Okay, Okay, and then A and F ni kita tak boleh panggil local sebab dia endpoint. Okay, dia endpoint. But if we want to consider this as your absolute boleh. Okay, sebab kalau dia yang paling rendah compared to dia punya jiran, then you boleh panggil dia as absolute. Sebabnya dia yang paling rendah, confirm dia yang paling rendah. Saya tak pasti yang ni yang mana yang paling rendah kat sini. Katalah kita panjangkanlah yang ni. Okay, so maknanya kat sini absolute minimum dia hanya ada satu value sahaja. Absolute minimum for this case maknanya for the interval from A to F yang paling rendah adalah at x equals to A. Tapi kita tak boleh panggil local minimum kat sini sebab dia tak ada jiran. Jiran dia hanya yang dekat ni, yang sebelah ni tak ada. Okay. And then absolute maximum is x equals to apa? Yang paling tinggi. Yang paling tinggi of all this. F. F tak. Okay. Maknanya D here. X equals to D. So, if you can see here, x equals to D appears twice. Sebagai absolute maximum dan juga sebagai local maximum. It's fine. Okay, tak semestinya local maximum, kalau dia adalah absolute maximum, maknanya dia boleh jadi juga local maximum. Okay, alright. Okay, now we have definition 3, the extreme value theorem. Okay, it is saying that if f is continuous on a closed interval a, b, then f attains an absolute maximum value fc and absolute minimum value fd at some numbers c and d in the interval a to b. Okay, the keyword here, we have to make sure that the function is continuous. Okay, so kalau function tu tak continuous, maknanya okay, it doesn't have, dia tak memenuhi kriteria absolute maximum and absolute minimum. Okay, so here for example number 1 here, find an extreme value minimum maximum for each function here. So for A here, we have a point A, B, okay, kat sini A, ni B, ni C, ni D, and this is E. Okay, so dia cakap F attains absolute maximum value FC and FD at some numbers of C and D. So maknanya nak cari yang minimum, maknanya kita cari point yang paling bawah sekali. Yang maksimum pula adalah point yang paling tinggi sekali, right? So for this case, example 1, absolute maximum dulu. Absolute maximum at x equals to what? At x equals to, nampaknya kita ada seri kan? B and D here. Then meaning that for this case, we have 2 points. At x equals to B and x equals to D. That's it. Whereas for absolute minimum, maknanya kita ada at x equals to C. Betul, C. Yes, C yang paling rendah. Okay. Then this is our answer. Okay, whereas okay, for number 2, is this function continuous? Okay, we have a breaking point here. So we can't claim the function is having absolute maximum and absolute minimum does not exist because fx is not continuous. Okay, it's not continuous. Macam itulah. At what point is it not continuous? At x equals to b. Okay, the function is not continuous at x equals to b. Because the extreme value theorem says the function must be continuous on a closed interval a to b. So, maknanya kat sini, it is not continuous in a closed interval a to c. Samalah a to c ke a to b because it's just a matter of variable. So, it's not continuous in the interval of a to c where it is discontinuous at x equals to b. Alright, now proceed to example 3, number 3 in example 5 here. This one simple, sangat simple. What is absolute maximum? Absolute maximum at x equals to, yang paling tinggi definitely point B kan, at x equals to B. Absolute minimum at x equals to C lah, yang paling rendah ni. Alright, okay, so that's it for example 5. Alright, so now we come to the next section, critical points of a function. We have two more definition here. Definition 4, a critical number of a function f is a number c in the domain of such that either that value of c will make the function f prime c equals to 0 or f prime c does not exist. Okay, then what is the relation between definition 4 and definition 5? Let's proceed. If f has a local maximum or minimum at c, then c is a critical number of f. So maksudnya kat sini, okay, kalau tadi daripada graph, senang je kita boleh tilik je graph tu and identify sama ada benda tu local maximum, local minimum, absolute maximum or absolute minimum. But what if graph tak ada? Then what is given to you only the equation? So adakah you all akan lukis graph tu dan tengok daripada situ? Okay, yes, it may be, but there is a way by having this definition 4 and definition 5. Maknanya untuk determine local maximum, local minimum at a value of c, maknanya kita kena, c tu adalah sebenarnya critical numbers. What are the critical number? The critical number is the value that will make your f prime c equals to 0 or does not exist. Okay, nak buat you faham senang. Kita try example 5 ni. Okay, example 5 ni, given y equals to x cube first. Okay, kita try for y equals to x cube. So y is equals to x cube. Then maknanya kita nak cari f prime or y prime or dy over dx equals what? 3x square. So with this, we let it equals to 0. Okay, we let it equals to 0, definitely x akan dapat apa? So, kalau tiada x dengan kosong, so x equals to 0. So with this, we have x is equals to 0 is our critical numbers of x. Okay, and then the question asks, okay, maknanya ada satu je lah tu, x equals to 0. And the question asks you to sketch both function and identify any local or absolute maximum minimum. Okay, saya rasa yang ni you memang of course tahu kot. Y equals to x cube. Macam mana graph dia? Okay, the graph looks something like this. Betul tak? This is y equals to x cube. Then we have this point. Kosong. So, just now we say that for y equals to x cube, dia punya critical number is x equals to 0. Okay, so kalau it is a critical number, is it confirmed that it is going to be local minimum or local maximum? Tak lagi, tak semestinya ya, tak semestinya. Okay, so for example this one, you see this is x equals to 0. Looking at this graph, then what we can conclude at x equals to 0, is it local minimum or local maximum? No, okay. It is not. At x equals to 0 is neither local maximum nor minimum. Okay, dua-dua tak. Okay, because dia bukan paling tinggi, dia bukan paling rendah because we have down here, and dia bukan paling tinggi because the curve keep on going up. Alright, so we're done with y equals to x cube. Now let's proceed for y equals to modulus x. Okay, so for modulus x, semua orang tahu kan y equals to modulus x ni maksudnya kita define dia as equals to x if x more than 0, negative x if x less than 0 kan. So maknanya kat sini y prime for modulus x is equals to, okay, equals to differentiate x, you dapat apa? 1 if x is more than 0. Silap ni, kat sini 0 if x equals to 0. Okay, and differentiate 0, you get 0 if x equals to 0, and negative 1 if x less than 0. Okay. Okay, so now what can we conclude? Y prime 0. Okay, y prime will be 0. Okay, y prime will be 0 when x is equals to 0. Okay, y prime equals to, can we say that? Okay, y prime equals to 0 when x is equals to 0. Okay, if you remember, okay, this is not correct. Okay, if you remember in chapter 3 part 1, okay, ingat tak kita dah discuss f prime x, okay, f prime x, okay, where we have when x more than 0, okay, the fx is equals to, f prime x is equals to 1, less than 0 is equals to negative 1. Okay, so here what we can say, f prime 0 here, because limit, okay, f prime x as x approaching 0 does not exist. Ingat tak? Okay, because limit from the left and limit from the right is not the same. Kalau you tak ingat, please refer back, look back at my video, okay, in chapter 3 part 1, somewhere there we did discuss, okay, where we're saying that for y equals to modulus x, fx is not differentiable at y equals to 0. Ingat tak? Okay, at x equals to 0, because the function dia tu macam ni kan. Okay, the function dia macam ni. This is y equals to modulus x. So 0 is a corner point. Okay, so meaning that f prime 0 does not exist. Okay, f prime 0 does not exist. Okay, f prime 0 does not exist. So meaning to say, you see here, critical number is either when the function is equals to 0 or it means the f prime x does not exist. So, maknanya kat sini it satisfy lah. At x equals to 0 is a critical number for modulus x because f prime 0 does not exist. Okay, f prime 0 does not exist. Okay, so I've concluded kat sini f prime x equals to modulus x. This is the graph. Saya dah jawab dah for B tadi. Ini soalan B ni untuk y modulus x. And then daripada sini juga maknanya the critical numbers in both function, the critical number, okay, the critical number for y equals to modulus x is at x equals to 0. Kenapa is at equals to 0? Because f prime 0 does not exist. Okay, yang ni. F prime 0 does not exist. And then from we sketch B, kita nampak kat sini at x equals to 0. Okay, is absolute maximum ke absolute minimum? Paling rendah ke paling tinggi? Paling rendah, right? So x equals to 0 is absolute minimum. Okay, for this one, x equals to 0 is absolute minimum. Alright, so with this, we have completed chapter 2, completed third part of a synchronous lecture.